yesterday, we're on 2.4, right? Yesterday, 2.4, we introduced you to complex numbers and that imaginary number, which was the square root of -1, correct?
Yes.
Okay, so we had the square root of -1, and we have to have those negative ones because we have to be able to deal with those numbers and actually produce something when we're done. We need a placeholder there. So we've talked about conjugate pairs before when we talked about difference of squares, and that's what they factor to. And yesterday I kind of brought them up too because you noticed that when we were working. Now we have complex conjugates, okay? I gave the example yesterday. If you called every rectangle a square, would you be right? No. But if you called every four-sided object with two sides at least the same, all that different. A rectangle, would you be okay? Yes. So if you're going to call a complex conjugate, that's fine. It better have an I in it. That's what makes it a complex number, yes? But if you just said conjugate because of the middle, everything was the same except the sign in the middle, then that's okay. Does that make sense? I don't want you calling X.
You can't do math.
Deep breath. Nope, I did it with pre-calc today, so
sad.
I'm going to do it here. I may have still frozen. That may be the problem. Okay, so I don't want you calling X minus 3y and X plus 3y. I don't want you calling them complex conjugates because they're not. They're just conjugates. Does that make sense?
Yep.
So you can call a complex conjugate just conjugate, and I'm okay with that. But don't be calling things that aren't complex numbers because that's a big difference. Okay, that's a big difference. So a complex conjugate, we know when we FOIL conjugates out, those middle two terms zero out every single time. So that's its job. In a complex conjugate, when we FOIL it all out, when we distribute it all out, its job is to come up with a real number without the I. Okay? So over here, I have A plus BI, A minus BI. Complex conjugates, yes? So when I FOIL that out, I get A squared minus ABI plus ABI minus B squared I squared. Middle two terms zero out, just like they should, correct? A is A. Where'd this -1 come from? I squared. So now that -1 makes my B what? Positive. Okay? So then I have two real numbers I can add together to get one real number. So I have 7 minus 8i and 7 plus 8i. Are they conjugates of each other? Yes. So when I FOIL them out, 49 minus 56i plus 56i, and I'm going uphill, plus 64. Minus 64 I squared. I need to recalibrate. Okay, so I have that, yes? Middle two reduce out. What does this do? -1, so it makes it a positive. So I have 49 plus 64. And I don't know why I drew a line over it. I just did. So 113. So I came up with a real number. Okay, that's the purpose of complex conjugates, is to get a real number. Because we can't have complex numbers or imaginary numbers in the denominator of things. Can't have it. Because if I'm going to write it as standard form, that is A plus BI, correct?
Yeah.
And that I needs to be in the numerator. So we can't have it in the denominator. So I'm just going to rewrite this. So I have -2 plus I. So its conjugate would be -2 minus I, correct? That first one doesn't change, ever. If you change the signs of both of them, the middle two terms are not going to reduce out. So when I FOIL that out, I get a +4, yes?
Yeah.
I get a plus 2i, a minus 2i, and a minus I squared. FOILing it, right? Choo, 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 choo.
0.
Okay, 0 out. So I have 4.
-1.
Four
Oh no.
I have minus a negative 1
Plus 1.
plus 1, so I get what? 5.
Fifth.
Okay? So again, what is the purpose of a complex conjugate?
That.
To get a what?
Real number.
To get a real number. Yay! Okay, I'm going to try to calibrate this before we go to the next one.
Please don't mess up your recording.
Well, no.
Okay. Okay, so it says simplify a quotient with complex numbers. Write your answer in standard form. Again, the whole purpose of this is to get that imaginary number out of the denominator. Yes? Can't have it. The only way I'm going to get a complex number to be a real number is to multiply by its what?
Reciprocal.
No. What did we just go over?
I don't know.
That's how you taught
Conjugate.
us.
The only way, no, I did not teach you that. And that word has not come out of my mouth today.
Multiplier
Okay.
reciprocal.
The only way I can get a complex number to become a real number is by multiplying it by its conjugate. Okay? So, and I don't care about the numerator, right? Because that's where the I needs to end up. So if there's an I in the numerator, I don't care. I only care if it's in the what? Denominator. So I have 10 over 2 minus I. Can't have imaginary in the denominator, so I need to multiply by the denominator's what?
Conjugate.
Conjugate. Woo-hoo. Okay, and I can multiply anything I want as long as I multiply both, yes?
Yeah.
So what is the conjugate to 2 minus I?
2 plus I.
2 plus I. Now, I am going to tell you in the numerator, I am not going to distribute that 10 because my hope is that maybe it reduces with whatever I get in the denominator. It may not, and I may have to distribute it, but it'd be nicer to keep it out than have to distribute it in and then factor it back out, wouldn't it?
Yeah.
Okay, so now,
Why would it be 2 minus I? Couldn't it be
oh, it's plus. I just didn't. Yes, it has to be exactly the same. Yes, I have to do exactly the same numerator. What?
You put it on the 10.
The second one.
Oh, because I was looking up there. Okay, so yes. So now in the denominator, I FOIL out, yes.
Yeah.
What is going to always happen to the middle two terms because these are conjugates?
0 out.
They're going to zero out.
0.
Okay. Now, I would advise you to FOIL it all the way out because what happens, because you're not used to conjugates really well yet, right? What happens if you don't write the right conjugate? If
You're
when
gonna
you
get it.
multiply it out, are you going to be left with the middle terms?
No.
Yes.
Oh, yeah.
And then you're going to know that you did it wrong. Okay? So I'm going to FOIL it out. So I get 4 plus 2i minus 2i minus I squared. Yes?
Yeah.
Okay? 0 out.
Equals 5.
This right here equals what?
Negative 1.
Negative 1. And a negative 1 is
Positive 1.
positive 1.
4 and 1 is 5.
So I have 10 over 2 plus I, not that, 10 times 2 plus I over 5. Now, if I would have distributed that 10 in before I could reduce, I would have had to factor it back out, right? But now I just see, does 5 go into 10?
2 times.
2
Yes.
times. So that is a 2, and now I distribute in what I have left. And I get what? 4 plus 2i. Yes, Garrett?
How'd you get the 4 plus 2i minus 2i towards the top?
I FOILed this.
Okay. That makes more sense.
So is this in standard form?
Yeah.
Yes.
So I'm good.
That makes sense.
So I have 80 over 2 minus 6i. I can't put that in standard form because why?
You have I as your denominator.
I have an I in my denominator. I have an imaginary or a complex or whatever you want to call it. It's in the denominator, right?
Multiply by the
So,
conjugate.
I need to multiply by the conjugate, both denominator and numerator. And what is the conjugate?
2
2
plus
plus
6
6i.
2 plus 6i. So you finish the problem.
Okay.
Now remember your hint. If it's just one term, leave it out. So you don't have to do double work, right? You can distribute it, it won't hurt you, but then you'd have to do some extra work.
How would you know if you have 100
What?
after you, after you have the 80? I did this wrong.
You do it right.
I had the
Oh, yes, because the other one's fine, and you're the one that caught me off.
I just wrote down the equation. How do you know when you want to do the 80 parentheses 2 plus 6 foil? Oh.
You have to foil it. Yep.
Forgot about that.
And yeah, don't forget be putting your parentheses there, guys. Does that change the problem completely? Yeah. You're not just distributing -6i, you're distributing the whole thing, right? So parentheses do count. I hate that books, like, I think they're trying to save ink. I don't know. You need parentheses around things. They make a difference.
Did you know that ink is actually more expensive than human blood?
Never
I
tried
don't
to
think
buy
that's true.
human blood.
It is. Ink is more expensive than human blood. Where'd you see that?
Well, I mean, human blood is a little more accessible.
Well, a gallon of water is more expensive than a gallon of gasoline.
Where can you go
No
buy?
problem.
Where can you go buy a gallon of blood or
A hospital.
You can't
You
buy
can't just
blood in the
buy
hospital.
blood.
Or no, you just suck
Get
it
it
from
straight
your
from the
suck
tap.
it from yourself.
But you
Okay,
can't buy
let's get back on track.
But then you
Okay,
use the hospital
so my
blood.
numerator is 80 times the quantity 2 plus 6i, yes?
Good.
Okay, my denominator, when I FOIL it out, I should get 4 minus 12i plus 12i
minus 36i squared.
36i squared. So, 0 out. This I squared makes this say what? Positive 26. Or 36, not 26.
36.
Okay? So, then I have 80 over 2 plus 6i all over
All over the
40.
40. So I have 4 plus 36, yes?
Mm-hmm.
Can I reduce?
Yes.
Yes.
By 2.
Okay, by how about 40?
That's what I meant.
Okay, so this
I meant it
reduces
goes
to.
there 2 times.
Oh, okay. So I have a 2, so what do I need to do with that 2?
Distribute.
Distribute it. So I have 4 plus 12i. Is my answer.
Yeah.
Now, guys, they are not all going to reduce out.
Why?
They aren't.
How dare you?
Okay, so if I have 7 minus 4i, can we stop the side conversations, please? 7 minus 4i divided by 5.
No.
That's what I finish with, okay?
Oh, okay.
Is that in standard form?
Yes.
Wait.
No.
No.
Why not?
Standard form is a
7 over
plus
5
bi.
minus 4.
Real I. Yes?
Yeah.
And is that what I have there?
No.
No. Okay, when I add fractions or combine them, they have to have common denominators, yes? And then when they come together, you add or subtract the numerator, and the denominator is the denominator. So can't I pull them apart the same way? Yes. So this would be 7/5 minus 4/5
That would be 3
I. And it needs to be very obvious that that I is off to the side. It cannot be, it's its own number. It can't be mixed. Now, when I multiply 4/5 I would get 4i over 5, correct? But when I'm done with it, that's what it needs to look like. Now, the nice thing about that is if I had maybe 7 minus 4i over 5, say that again. 7 minus 5i over 5. When I did this would be 5 over 5, so it'd be 1, correct? So I can simplify it further. But your answer has to be in standard form when you're done. So if you end up with a fraction like this, you have to just pull it apart.
But isn't that improper fraction of 7 over 5 not a real number?
7 over 5 is a real number. It's a real number, it's not a rational number. Yeah, it's a rational number. Rational number is anything to be. It's a real number, yeah. It's not a whole number, but it's a real number. Okay. Next one.
Well, you have an I in the numerator, so you're good there.
Yeah, in the numerator, I'm all fine with that I, correct?
Yes.
But this is a whole quantity, and I need to remember that because I'm not just going to have one thing. I'm going to have to distribute it out, aren't I?
Yes.
Okay, So I need to clear the bottom. So what would be the conjugate of negative 1 plus 2i?
Negative one minus two I.
Negative 1 minus 2i. Good job leaving the first term the same. So negative 1 minus 2i. You guys think you can go from there?
Probably, sure.
I believe in you.
Oh, no.
I don't even think you would have had time to do anything before you said oh no.
I did.
Like you literally looked down. Oh no.
Guys, FOIL. Yes?
Yeah.
FOIL on the top, FOIL on the bottom. So do it.
Ooh.
Or distribute. I need to quit using FOIL.
Yeah, gee.
You need to aluminum.
Aluminum.
Yeah, aluminum. And people be like, what is aluminum? Aluminum? I can't say it.
Aluminum. Foil.
That was the idea, yeah.
FOIL. Use that algebra 1. First, outer, inner, last. Austin.
What?
Look. 4 times negative 1, 4 times negative 2. Negative 3i times negative 1, negative 3i times negative 2i. Foil it out.
Fun fact, the only reason I know how to do that is because I watched Khan Academy.
Okay, so negative 8i
Is it fun though? Is that a fun thing?
minus 4. I don't know why I did it that way, but I did. Plus 3i plus 6i squared. Is what you should get in your numerator.
Okay.
And you should get, I don't know why I
I
put negative.
basically have that.
Oh, that's what I
1
have. Why'd you put
plus
negative 8i first?
2, I don't know. Okay, 1 plus 2i minus 2i
minus 4i squared.
minus 4i squared. Okay, so I need to simplify the numerator, like I need to combine terms in the numerator and the denominator this time, correct? Okay, so this I squared is going to do what to the 6?
Make it negative.
Make it negative because I'm multiplying by negative 1, correct?
Yeah.
So this would be a negative 6. So then I would have negative 4 and negative 6, so I'd have negative what?
15.
10. And then I have negative 8i and positive 3i, so I have negative 5i.
Oops, I did that.
So that's my numerator, yes? So my denominator is zeroed out because that was the whole point of multiplying by the complex conjugate, correct? Okay, so this I squared is going to make my negative 4a what? Positive. And I have 1 plus 4 is 5.
You can factor that.
I
Not
can
factor.
factor, they have,
Factor it out.
I can factor out a 5 in the numerator, correct?
Yes.
Okay, so if I factor out a 5 in the numerator,
You
I
have
have negative 2 minus I over 5. So I'm left with negative 2 minus I. Is it in standard form?
Yes.
Yes. Now, if you were here and didn't think about factoring, if I'm here not thinking about factoring but standard form would be to divide that up, yes?
Yeah, so it'd be
So it'd be negative 10 over 5 minus 5 over 5 I. And what would I get when I reduce those fractions?
negative 1, negative 2.
That,
Or negative
I
9,
forget
negative
that.
2.
okay? So remember you have to reduce. Somebody in last hour was like, is this the answer? I'm like, no. And they got mad at me because I wouldn't tell them to reduce. Should you always reduce fractions?
Yes.
Yes, and I shouldn't have to tell you to do that, right? Especially when they're even numbers.
Well,
Okay, so remember you got to get us in standard form every problem, okay? Okay. Next thing we're going to do is solve. Solving, well, this one says factoring. Sorry, word factoring. I was skipping a slide. Factoring. We know how to factor if I gave you, let's see, 4x squared minus 9. Could you factor that?
Yes.
Yeah!
Is it difference of squares?
Most of us could, yes.
You should be able to, yes? Okay, if you didn't realize it was difference of squares, you could do a times c and you could do all that, right?
Uh-huh.
But since it's difference of squares, we take the square root of the first, yes, plus and minus, and the square root of last. Okay, that's how you factor those, correct?
Yeah.
So, but we don't have a rule for the sum of squares, do we?
No.
No, because when I FOIL this out, I get a negative 9, but I would need to get a positive 9. And do I have something that, like, if I take times itself, I get a number that would allow me to make a negative look positive.
No, it ties by itself.
If I have, do I have something that if I square it,
Yeah, it's a letter called I.
it's a letter called I,
Oh.
correct? If I square I get -1,
Mm-hmm.
and that -1 would allow me to change my negative to a
Positive.
positive. So, I have sum of squares. Everyone see these are perfect squares, yes? So we do exactly the same. We square, yeah. Square root of the first,
X.
x, okay, plus and minus,
Wait, why would it be plus?
Because
plus and minus.
It's always plus or minus.
So-
Not
so-
always.
What is the square root of the second?
Y.
Y. Okay, if I FOIL this out right now, I'm going to get x squared minus y squared.
Yes.
What do I need to add in there?
I squared.
I need to be able to get an I squared, right?
Add I.
So add I
Right next
to the second one.
Add I to the Y.
So now I'm going to FOIL this out.
Foil.
X squared minus xyi plus xyi minus y squared I squared.
Plus.
What is I squared?
1.
No, it isn't.
-1.
-1. So the -1 times the -y gives me a positive y.
Yep.
So I can factor the sum of squares exactly the same as the difference of squares, but I gotta throw in what at the end?
I.
An I. And the job of the I is turn the difference into the sum.
Can you do it in the first X?
No.
Oh no, because then I'll turn that negative.
Then it would turn out to be negative and you want it to stay the same. Right.
Oh, never mind.
What was the? Why is our answer the same as the question?
Because we checked our answer. Like,
Oh,
this is our answer
oh, that's. the
and this
actual
is our
answer.
check.
Oh, okay, I get it. now. I was like,
I was trying to show you how that it would work.
okay, I get
Okay.
it now. I get it.
So I got 4x squared plus 25.
Okay.
Okay, 4x squared plus 25. You're going, yes, I can factor that. And then you see what?
What kind of?
I don't know. I haven't seen it yet.
Well, no. You're like, perfect square, yes, I can factor that. What causes you the problem?
It's a song.
It's a
of
sum, not a
squares.
difference, correct?
So you just do the same thing, but
So
just
I
with the I.
do the same thing. What is the square root of 4x squared?
2x squared. 2x.
Kale, chill. Too much enthusiasm. Okay, what is the square root of 25?
5.
Five. So I plus and minus, yes?
At least you have someone.
And 5. And 5. If I FOIL this out right now, I'm going to get 4x squared minus 25.
So put an
So I need to put an I at the end.
An I.
So this is my answer.
And then it's.
Let's check it.
And then. Do some.
Looks good to me.
How do I do that?
Well, you
Foil.
Tell me how.
Oh! 2
Four.
and 2. So
2 times 2,
4x
4x squared.
squared.
Okay.
And then 2 to the 5i.
Okay, so negative 10i.
Yeah. And
Next
then
Next time. Put 2X.
Thank you.
you plus, and then 5 to the 2.
Okay. Totally wrong way to write it, but I wrote it the same way.
And then do 5 to the
So
5i, so it's
Negative 25i squared. So my middle two zero out because I do have conjugate pairs there, right?
and then it's a 1.
So it's going to be 4x squared. This is a negative 1.
Yeah.
So what does it do?
It makes,
Makes
it
it
a
a
positive.
Positive. Did I get what I started with?
Yes.
Eventually.
Eventually, yes.
Eventually.
Kale, please don't speak like that. I don't
I
You
know.
know,
I
please
got
keep
it.
speaking like
You
that.
do got this.
Okay. So, now,
I don't-
12x squared plus 3.
So we are screwed.
3.
That's 6.
Why don't we just like say no to the 3?
Okay, what should we always do when we get a
See
problem?
if you could factor
See
like
if there's-
out
they have a
the
common factor,
Yeah,
right?
that's what I was saying. 3.
3.
So
So I would have 4x squared plus 1, right?
Yes, that's what I wrote on my paper.
Is that perfect square,
Yes,
right?
yes.
Okay, so factor it. So you should have 2x plus or whatever I and 2x minus I.
Yes.
And you can have a 1 in front of those i's if you want, right?
Okay. Oh.
Why is it 2 again?
Because the square root of 4 is 2.
Okay.
Because you're taking the square root of the first number and the square root of the second.
And 3 don't equal 0.
What?
3 doesn't.
No, 3 doesn't equal 0. We're going to solve them in a minute. But you guys do 8y squared plus 18.
We're not solving that?
Yeah.
No, we're not. We're just factoring right now. We're going to solve on the next slide.
Okay.
Oh, so that's all.
Yeah. I mean, this just says factor. If you want to solve, you can, but the directions say factor.
Okay, I believe you.
Follow the directions.
And I think I got that right. Oh, I forgot. It was a 1 instead of an X.
Well, then that's minor.
No, you got it wrong.
Still, I got the entire thing wrong. I didn't get it right. Yeah,
You did.
I had 4
You should
He
and 9.
does
factor
not.
out 2 first.
No.
I had 4 and 9.
Because if you look at it, they're both even.
Okay, so the very first thing I should do is factor out a 2, yes?
Yes.
Even if they were perfect squares and had something in common, you should factor it out, okay? Because if they have something in common at the start, your factors are going to have something in common and you'd have to still factor it out at the end. So anytime you get a problem, a quadratic equation, or any polynomial, you should look and see if they have something in common and factor it out. Okay, so once we factor, you guys already
Window
got it
autopilot.
figured it out. What do I do with my factors? The whole purpose of a factor is to find a solution, yes? And so you put them equal to what? 0,
Oh,
and you have solutions, yes? So right here, we'll do it down here since I'm short and I can't reach. We all know that. We joke about it. Okay, so 2 can't equal 0, can it?
nope.
No. Now, if I had an x with the 2, it'd be 0, wouldn't it? Now, these two are going to be exactly the same, but one's going to be plus, one's going to be minus, correct? Okay? So how would you solve this algebraic equation? We're solving for y,
Minus 3i from both sides.
Minus
divided
3.
by 2y.
not 2y, just 2, yes?
Oh, yeah.
Okay, so my answer is y equals plus or minus
3 over 2i.
3 over 2 and then the I. Good job. The way you said it, I knew what you meant. 3 over 2 I. It's not 3i over 2, is it? It's 3 over 2 I. And that's what the next slide is.
What?
This is what the next slide is. Is that. So just like any other quadratic equation, it didn't matter that I now have complex numbers involved, does it? I do exactly the same thing. Now, can I graph 3 over 2i? Is it a real number? No, it's not a real number. I cannot graph it, but that is the solution. Okay, it's not a real solution, but it is a solution. Okay, so now, if you think about this yesterday, when you solved these, because you solved them yesterday, right? You would subtract, you would have what yesterday? Subtracted 4, and then
Square root of both
take
of
the
them.
square root of both. So you would have gotten x was plus or minus 2i.
Yeah.
correct?
That's where I wanna go.
But now, you have the sum of squares and the capability to factor that, yes?
Mhm.
So what would that factor to?
X plus 2. And
X
minus
plus
2.
2i and x minus 2i.
I,
Set them both equal to 0, and you get an answer of
X equals plus or minus 2I.
That's the same.
That was
it's
cool.
exactly the same. Now, but up here, you had to remember what?
The plus minus.
Plus or minus.
No, there you go.
Down here, did I have to remember to do that?
No.
No, because it's there, isn't it? Okay, so that's an advantage of doing it this way. So today when you have them, please factor them so you can remember that factoring happens, okay? So you think you can do the next one all by yourself?
No, but I'll try.
Try.
Try it.
If you get done with it, go to the next.
You don't have to.
Good eyes.
Yeah, good job, boss. You, why,
Okay, gentlemen.
That was mean, Kale.
I was mean.
Yeah,
You guys got answers yet?
I think. It's not right, but I have answer.
So it's non.
No. Alright, I got it.
Okay, what did you do, Austin?
Oh, put me on the spot like that?
Yeah.
Okay, so
I don't know. I just basically copied the first one.
Okay, so what'd you do?
I put 0 equals.
That's it.
That's it. Parentheses x plus 7i. And then another parentheses x minus 7i. And then I put under that, or yeah, equals 0, whatever.
Okay.
And then I did x equals plus or minus 7i.
And that's right.
Yeah,
Okay, you're just using a pattern, right? That's
yeah.
all you're doing. Questions.
Question.
If you didn't get that, you should have a question.
Now what about that one?
Okay, so what about that
Not
one?
equals
Well,
0.
let's
not equal.
factor a
We'll
5
factor out a
out.
five.
Why would I factor out a 5?
So you
Because
can't
five is
get
divisible by
lower.
both of them.
So do it.
No.
They're both divisible by five.
Could just stop.
I'm fixing it.
I don't care. You're just touching my hair.
What's so bad about that?
You got an answer already?
I do too.
Give them a minute.
Yeah, we're not on your level, I think.
Seriously.
I'll call in.
Level of
Yes.
complexity.
I don't want you to have to amputate. So put it down.
I want to amputate.
No, stop.
I'll do it myself.
Your parents ever tell you like when you got hurt when you were little and you inquired about it?
No.
And they'd say,
Have
"Let's
have you have we have to
Set it up,
amputate.
yeah.
Cut
I've
it
never
down.
been hurt.
I did that all the time. I hurt my knee one time. He grabbed an actual freaking saw, started cutting my knee.
Oh, he didn't start cutting your knee. You thought he was going to.
Like,
No,
Okay,
my
Isaiah, tell me how to do the problem.
Okay, so you factor out 5
Factored out of 5.
and the parentheses
And why did you factor out of 5, Isaiah?
because it makes the number smaller.
They're
And
both
easier to work
divisible by 5.
with.
Because I wanted to.
That's
I'm
what
gonna
you
work
say.
it.
They're both divisible
It would
by
have
5.
been
Okay.
x plus 5i.
Why?
5. And the parentheses.
Is 5 a perfect square?
No.
You need the square root of 5.
So 5 isn't a perfect square, is it?
Ow.
So now I just set everything equal to 0, correct?
Oh, sure.
Alright.
So here's 0 and here's 0. Does 5 equal 0?
No.
No. What would have to be there for it to equal 0?
A zero.
A variable. A variable. Okay, so this doesn't work. So now right here, you're going to subtract 5, yes?
Yes.
So I'm going to have x squared equals negative 5, and then I have to take the
Square root of this.
square root of it.
Reset.
So then you have x equals
Negative 5i.
Plus or
plus or
minus
minus
the square
root
of
of
5 I.
because the negative is I, correct?
Yeah.
And we don't have a square root of 5 that other than a calculator, correct?
Yep.
And so we're not doing that. We want exact answers. So we have to pull out that square root of -1 and get the I. So there's times we have to set it equal and just subtract it over, take the square root, right? But do we have to? Did we have to on A and B?
No.
No, but we had to on C.
C.
Now I probably wrote C wrong, to be honest with you, but that's okay. Because I'm pretty sure it's not supposed to be that. I think you were supposed to be able to factor it out and still have 25 in there.
Okay, dude.
But that's okay. Because you need to see the advantages over doing it. Okay?
I thought we were gonna do it like the first two.
So did I.
That's how I did it.
That's
Well,
what
but
I-
you couldn't. You
and
can't.
I erased it.
You can't do it like the first two because I have plus 5. 5 is not a perfect square, is it?
But you could have kept 5.
So you would.
Well, if you were to factor that, you would have x minus
2.5.
the square root of 5i and x plus the square root of 5i. Because you have to take the square root.
But that's still.
No, 2.5 is not the square root of 5.
Okay, so then if your x has a coefficient.
Say it with her, I say.
So then if 2.5.
Shut up.
Because 2.5 is
I know what you
6.25. Okay.
So then if x has a weighted coefficient of 1, then you can do it like the first two.
No, it's my 5. Oh, if it was x squared plus 25,
Yes.
yes. If it was x squared plus 25, you could do that. But you see, I could factor it this way because we just took the square root of the first,
Yeah, I
right?
started doing that. It
And the
just
square root of the
wasn't
second. And so when I set these two equal to 0, what do I get?
I get x.
I get
equals
right there, don't I?
that.
Okay, so you honestly can use the difference of squares and the sum of squares on any binomial as long as it's quadratic. But I don't think you want to walk around with like square roots of 7 in your answer, do you? And we don't think like that. We don't. So setting it equal to 0, subtracting 5, and taking the square root is the route that you would take. I mean, if you do it that way, more power to you. It's fine. It's not wrong.
Don't.
But it's not something that we readily think about. Okay. So that is done. We're done with our notes for today. And so you have the rest of the time to work on your assignment. If you are missing assignments and you want to like get your grade up, I would work on the stuff that's already in the grade book. But hopefully you all have your stuff done because we will have a quiz tomorrow. So you have a quiz tomorrow over yesterday and today. Okay?
What did you didn't tell us that yesterday?
It's been on the board all week.
Been on the board.
Oh,
Who puts up the board? Not me.
You have to write down stuff off the board every day.